No, it was the triangle problem that gave me grief.
Yeah, I was but on the last one, I got 2 negative answers, which I knew wasn't right.
Yeah.
Positive.
I planned on grading it last night because I had Mr. King grab the folder that I always keep my tests in, and the sub never put the tests in the folder, and I didn't tell Mr. King to look at my desk for them. So I didn't get them graded last night. That was my plan to have them graded last night. So I'll grade them today so that I can take a look at them. But I was hoping to get them done at dance because that's something to do with dance. So I'm just saying. That should be good. But I'll have them back to you on Monday. Hopefully they're better than what you think.
Take your time.
Take my time, huh? We are going to continue working with quadratics. The next 3 sections, we're going to look at different ways to solve for the squared term. So factoring is just one way, and only works for certain types of problems. So we are going to look at other methods that we can use to solve for x squared, t squared, y squared, whatever the squared variable happens to be. You will see that I will be giving you short 3 to 4 question factoring quizzes, like that little half sheet of paper, throughout the chapter. You will have another quiz, and I didn't erase that one over there, but there will be another quiz, not next week, but the week after, on the methods of solving, and then the last part of the chapter is to take all the methods of solving and start graphing. So it kind of pulls everything together. We'll graph what these look like and find a lot of important parts of them. So it's a lot in one chapter. There will be a chapter test, but we take a quiz on factoring, a quiz on solving, and then we will have a chapter test at the end. So I asked you to do these yesterday. If you did them after the quiz or you did them for homework, just as a little review to get you into the radical thought process, because a lot of the answers we're going to be looking at from here on out, square roots and radicals. When it's factorable, you get nice answers. If we cannot factor a problem, then we generally will have answers that have square roots in them. And those square roots. So just a little refresher. I'm going to go through these pretty quickly. The square root of 100 is 10. That's called a perfect square. Doesn't want to work today. Ooh, there it goes. Okay, so 10. Maybe. Let's pretend 10 is there. Yeah, right? The square root of 200, Peter. How would you do the square root of 200? Right, so you're looking for a perfect square that goes into 200. Try and restart this one more time. And the square root of 100 times 2 makes the square root of 200. So therefore you get 10 and the square root of 2. And then the last one, the square root of 75. So Chris, if we have the square root of 75.
So you could break it up into square root of 25 times square root of 3.
Yeah, so 25 is your perfect square, 3 is that leftover piece, 75. Let's see if this works. And then that becomes 5 square roots of 3. So that's called simplifying the radical. You're simplifying the square root, choosing a perfect square, something that you can take the square root of, and then whatever is left over. So that piece that multiplies to be the square root of 75. There are 2 little properties on here. And those, properties not yet. 3 definitions and then 2 properties. How would you explain a square root? Josh, what would you say, or kind of explain what a square root is? So you said b squared, not b. Then b is equal to the square root of a, is that what you said? Yes. So what does that mean, Josh? Give me an example. Yeah. So 5 5 squared is 25, so then we would say the square root of 25 goes back to the 5. So that's kind of what that little algebraic statement means. If you have a number squared, then I could take the square root of it. It's a perfect square. There's two other words. We have the word a radical versus the radicand. So if I have the square root of A is any number. What part is the radical? Peter. Yeah, this symbol. So the radical is the actual symbol. We say square root, but we will learn this year that it could be a cube root, a fourth root, a fifth root, a sixth root. But the symbol is the radical. The actual symbol is called a radical. The radicand is the number underneath. And it could be a variable, it could be a number. So whatever's underneath the symbol is called the radicand. So the radical is the symbol. Generally we refer to it as a square root. It will change. Whatever's underneath is our radicand. And then there are two properties underneath here. The first one is the product property, which says if I have two numbers underneath, I could separate them individually and look at them as the square root of A times the square root of B. You're allowed to split up a square root. So the square root of 18 should be the square root of 9 times the square root of 2. Two numbers multiply to be 18, I can split them up. We're using a 9 because it's a perfect square, so that's 3 square roots of 2. The quotient property works similarly. I can look at those two fractions, the numerator and the denominator, two parts of the fraction separately. I can take the square root of A and the square root of B individually. So when we look at fractions throughout the year, we're going to think of them as really two separate pieces. Do something to the top, do something to the bottom. So this would be the square root of 2, and then just 5. I know, rough day with the smart board. So square root of 2 over 5.
Oh, there it goes.
Did it go?
Yeah.
Yep. And then down at the bottom, this is where you were asked to stop, just simplifying these square roots using some of the properties. Jack, what would you do with the square root of 24? A. Right, square root of 4, square root of 6. And Jack, the square root of 4 becomes? So 4 is the perfect square, and then we have the square root of 6. Leah, how about the square root of 5 times the square root of 18? What would you do there? Yeah. So do the multiplication. It says times. What is 5 times 18? 90. So multiply those two together. So the multiplication symbol, you're allowed to multiply the numbers underneath. They're both square roots. And then Leah, what did you do with the square root of 90? Right. So multiply them together to get the bigger number, and then we'll break down that bigger number into perfect squares. So this becomes 3, and then the square root of 10. Letter C, we have the square root of 9 is 64ths. So Nick, that would become? Yeah. So looking just at those separately, just think you're taking the square root of each number individually. And then Cole, for letter D, the square root of 5 times the square root of 10.
I multiply it together to get to 50, and then it goes 5.
Right. So this is 25 and 2, 5 square root of 2. So if there's a time symbol, multiply those numbers together. Get the bigger number and then break that bigger number down. So perform the operation and then simplify. Questions? Hopefully that was pretty much a review for you. The top of the page has some fractions in them that we're going to look at, something called rationalizing the denominator. Yes.
Can I borrow a pencil, please?
Oh yeah. Probably needs sharpened. There's 2 up there, 1 in the back. I think one more time. So at the top of the page, we have something called rationalizing the denominator. Does anybody know what that means? Nick? Right, the bottom of the denominator cannot be a square root. So a fraction is really particular. The denominator of the fraction has a lot of rules that go along with it. One of the rules is that you're not allowed to have a negative number in the denominator. Another rule is that you're not allowed to have a square root in the denominator. So rationalizing the denominator is taking the square root or eliminating the square root from the denominator of the fraction. It's a way of simplifying the fraction. And you will see this process used anytime you have a radical, and that radical is in the denominator of a fraction. So it's called rationalizing the denominator. It's a process to simplify a fraction by getting rid of the square root. So if you look at letter A, we have the square root of 5 halves. Can you take the square root of 5? No. Can we take the square root of 2? No. But I can write it at least as the square root of 5 divided by the square root of 2. I can at least separate it. So because there's a square root in the bottom of our fraction, this is considered unsimplified. And we're going to rationalize the denominator so that I only have a 2 on the bottom, or a whole number on the bottom, and no longer a square root. How do you think you could get this square root out of the denominator, Michael? So multiply it by not just 2, you're really close. The square root of 2. So we're going to multiply the denominator by the square root of 2, by that exact square root that's sitting in the denominator. Because then Michael said you would have the square root of 4 on the denominator if I multiply them together. Michael, what would be on the top if we multiply them together? Square root of 10. And then Michael, the square root of 4 becomes 2. So we rationalize the denominator by multiplying both parts of the fraction. We have to keep it equivalent. So whatever you do to the bottom, you do to the top. Just like an equation, whatever you do to the left, you do to the right. So to rationalize it, you're multiplying it by the square roots that's there. Because by multiplying it with that square root, it eventually eliminates our value. And we just have this 2 instead of this square root. So if we look at letter B, you can do the same thing. So really think of this as the square root of 8 and the square root of 3. So this process is called rationalizing the denominator. You're getting the square root out of the denominator. Sadie, what would you multiply by?
Square root of 3.
Yep, so whatever's on the bottom, square root of 3, square root of 3. Sadie, the top becomes?
Square root of 24, and the bottom is square root of
Square root of 9, yeah. And we know the square root of 9 is just 3. So when you have a square root times a square root, you can see that it becomes a square root of 9, or another way of thinking of it, they cancel each other out. And you just get the 3, you just get the value that's underneath the square root by multiplying it by itself. Is there anything we need to do to the square root of 24? Josh? Yeah, the square root of 24 has to be simplified. So that becomes the square root of 4 and the square root of 6, which is 2 square roots of 6 over 3. So the goal is to get a whole number in the denominator. So you cannot have a negative number and you cannot have a square root. Those are considered unsimplified fractions. get rid of the square root fraction. Any questions? So we are going to look at today solving equations, and we're going to use this process of square roots to help us solve equations. And you will see that we might have some square roots in the answers. Others might turn out nice. But we have something that is squared in our problem, which makes it a quadratic, and that's what we've been working with factoring. These problems have parentheses. We have a 1/4 outside. You have this parentheses squared, and then you have an 8. And our goal is to solve. And anytime you're solving, you're trying to get x by itself. So what would be something that you could do to letter A to solve the equation? So just thinking about like what you remember about trying to get x by itself. What could be one thing that we could do to solve this? Gavin, what do you think?
Multiply the reciprocal on both sides.
Yeah, so there's a 1/4 there. And if there's a fraction, generally we want to get rid of it. So he said multiply by the reciprocal on both sides. Oh my gosh. So we will multiply by the reciprocal, which would be multiplying by 4. So the 4 and the 1/4 cancel. You still have y minus 6, and it's still squared. And now we have 32. So we got rid of the fraction. Now we still have to try and solve and get the y by itself. So what else do you think we could do to solve for y? To try and get y by itself? Josh? Why would you square root both sides? Yeah, so our goal is to get rid of the thing that's squared. And the opposite of something that's squared is a square root. So we're going to try and do the opposite. It's called undoing the square. So instead of having something squared, we're going to undo it by taking the opposite of it. Opposite operations cancel. So if I have multiplication and I use division, they cancel each other out. If I have addition and I use subtraction, it cancels each other out. If I have a square and I take the square root, it cancels it out. So literally, those operations are opposites and they cancel each other out. On the other side, we have the square root of 32. And we just did a couple of examples with square roots so that we can break this square root down. You will not get a decimal unless it specifically says to have a decimal answer. We're going to keep everything exact. So what is the biggest perfect square that goes into 32, Peter? 16. So 16 times what? 2. Now, this problem here is a little different than just the other ones that we were working on because this is an equation. So I know this becomes 4 square roots of 2. But when we did the factoring problems, in probably 95% of the factoring problems you did, how many parentheses did you have in your answer? Or how many x's did you have in your answer? 2. And that's because this graph is a parabola. The graph, which we haven't really looked at yet, is a U. And it has 2 sides. It has a side on the left and a side on the right. Because of those 2 sides, the left being a negative side and the right being a positive side, every time we solve for something that's squared, I should still have 2 answers. And when you take a square root, we have a plus and a minus that appears with my answer. And that's because 4 times 4 is 16, but negative 4 times negative 4 is still 16. So every time you take a square root and you're solving, we really have 2 answers in the problem. And that accounts for the fact that I have a left and a right side of this U, this parabola, that eventually we'll get to graph. Questions with that plus or minus part? The last thing that we have to do to get y by itself is what? How do you get y by itself? There's one more thing. Chris? Add 6. So we're going to add the 6. You're going to put the 6 in front because it's our integer. It actually is more important than the square root. And then we place the plus or minus in between, and then we have 4 and the square root of 6. Do you think you can add these two numbers together and get 10? Or subtract them and get 2? You cannot. And the reason you can't is because these are two different types of numbers. You have an integer, and we have something called an irrational number, a number with a square root. They are not the same types of numbers. This value is by itself. This 4 is attached with the square root. So our answers are going to look a little different. They're no longer going to be nice answers. So that would be my final answer. I don't have to write it separately. I have 6 plus or minus 4 and the square root of 2. I still have 2 answers there. That plus or minus still means there's 2. We could put it in the calculator and get a decimal. This would be just a random decimal answer, 2. Questions? So let's see if we can do this again, just to get a little more familiar with it. Jack, what would you do first for letter B?
Multiply by negative 5.
Yeah, multiply by -5. -5 times -5, Jack, is 25. What then would you do, Jack? So we have to take the square root to get them to cancel. And you get x minus 4, and he said the square root of 25 is 5. What else is the square root of 25 also, Jack? -5. So positive and negative. That's called plus or minus. Because 5 times 5 is 25, but -5 times -25 is also positive 25. So I actually have 2 nice answers here. You can think of this as really having 2 separate equations. One equation would be x minus 4 equals positive 5. The other equation is x minus 4 equals -5. That's what the plus or minus actually is saying. And if I have a nice number here, I can find those 2 specific answers. Whereas over here, having a square root, because it's a square root, we cannot find 2 specific answers. So Jack, what would the 2 answers be?
X equals 9 and x equals -1.
Right. So here I get 2 nice answers, a 9 and a -1. So you can kind of see the difference of the type of problem that we could have and the type of answer that we might have. See if you can solve letters C and D underneath. So trying to think, there's a 3 in front of both of them. What would you do with that 3? One of them works out a little nicer than the other. The plus or minus is going to be the tricky thing to remember and get used to. Brady, the square root of 9 is 3, but also plus or minus 3. Oops, that was supposed to be plus or minus. So you should get 2 answers, Brady. Yeah. And I think you have them flipped. So if I have x plus 2 equals 3 and x plus 2 equals -3.
Oh, the -5.
There you go, -5 and +1. So +1, the x plus 2, it's a plus 2 there, So getting that by itself gives us a positive 1 and negative 5. And then letter D, working through the same way. Michael, can you take 40 divided by 3? No, without getting a decimal. So unfortunately, we got a fraction in this problem. Gonna just keep it as 40 divided by 3. I can't do anything else with it. It doesn't reduce, it doesn't simplify. We don't want decimals. And then we'll take the square root of both sides. And over here, remember we're thinking of this as the square root of 40 and the square root of 3. Michael, what do you think you need to do with the square root of 40 and the square root of 3? Excellent. So we need to rationalize the denominator. God bless you. So we're going to multiply by the square root of 3. So rationalize the denominator. We can't keep a denominator with a radical underneath, so we're going to do this rationalizing process. Michael, the square root of 40 times 3 is? Square root of 120. And then 3, square root of 3 times the square root of 3 is going to be the square root of 9, which is just 3. I'm going to put a plus or minus in front because we took the square root to solve. Is there any other simplifying that we can do to this fraction? Peter? So the square root of 4 becomes? Nice. So 2 square root of 30 divided by 3. And then Peter, in the same step, let's get that 2 to the other side. So x would be equal to? Perfect. It's an ugly looking answer. Doesn't look pretty like the other one. Integers are nice answers. They make you feel better about the problem because you get a nice answer. So we have 2 because we had to get x by itself. And then 120 is the square root of 4, which becomes 2, and the square root of 30, and then divided by 3. This 3 here is outside the square root. You can't do any other simplifying with it. So I can't take square root of 30 and divide it by 3 because you have a square root number versus a regular whole number. So your answer just kind of remains like this. Questions? So the top of the next page has a word problem. And we ended the last section with some word problems. And we're going to continue to look at word problems as we work through the next couple of sections. And this one here, it's our model for a dropped object. So if I have any object and you drop it, you know it falls. Hopefully. Unless somebody catches it. And here's a water balloon. So it says that a water balloon is dropped from a window 59 feet above the sidewalk. That would probably hurt if it hit somebody. 59 feet. It's probably about 4 or 5 stories. How long does it take for the water balloon to hit the sidewalk? So we have a formula for any object that is dropped. And this is just a dropped object. In the next section, we'll talk about a thrown object. And that formula says h equals negative 16t squared plus another h with a little 0 as a subscript. I'm going to tell you what everything means here. So this is our falling object model. If something is just falling or being dropped, this is the model that we use. This represents the initial height. And that means where did it start? So where did the object start from where it was falling or where it was dropped? What do you think T stands for? Time. Yeah. And then the other H would be the end height. So the little 0 means the original height, the beginning of height. The height when the time was 0 before the object was dropped. The height on the other side is where does it end? So does somebody catch it at a certain height, or maybe it just hits the ground? So again, looking at our problem here, a water balloon is dropped from a window that's 59 feet above the ground. So 59 feet above the ground, or the sidewalk, would be my initial height. That's where it's dropped from. So I'm going to plug that in. Bless you. The negative 16t squared. That negative 16 is due to gravity. So we have a gravitational pull on the Earth, and because of that, that negative 16 is there. An object falls at 32 feet per second, and based off of a trig formula, you multiply that by -1/2 because it's falling, it's negative. If you're on a different planet, like if we were on Pluto, or I guess Pluto isn't a planet. Saturn, Jupiter is a planet or no? Sure. But if we were on a different planet, thank you, then this number would change because the gravitational pull is different. So a little bit of physics there. The end height. What number would I plug in for the end height? Thank you. Jack? Why 0? Yeah, the sidewalk is at ground level. So if it hits the ground, the height of the ground is 0. Our goal is to figure out how long it takes for something to fall. And when we figure out how long, we're finding out time. So we plugged a 0 in for the end height, a 59 in for the original height, and we're going to solve for time. How would you solve for t? How do you get t by itself? Sadie, what do you think? Yeah, let's get 59 to the other side. We're trying to isolate the variable. What else, Sadie?
Square root.
Before you do that, what else do we have to do to get t squared by itself? What else is with the t squared right now? What's in front of it?
Divide by 16.
Yeah, we're going to divide by -16. So we want to get rid of that number first. So t squared is going to be equal to 59 divided by 16, because a negative divided by a negative is a positive number. And then, Sadie, you would square root both sides. And I get t equals plus or minus the square root of 59 divided by 4. Now, if this is a word problem, and you told somebody that it takes the square root of 59 divided by 4 seconds to hit the ground, they would be like, okay. So what do you think we would do with word problems that we wouldn't do with the other problems, Jeff? Right, we're actually going to calculate this to get a number that makes sense. Because we want to really know, like, how long did it take the ball to hit the ground? So in your calculator, we're going to take the square root of 59 and then divide it by 4 to get a number in time that makes sense to you, that's relative to the problem we're working with. And then underneath it does give you a little information. It says reject the negative solution because time has to be positive. So the water balloon will fall for about blank seconds before it hits the ground. So about how long does it take the water balloon to fall? Oh, what did you get?
1.9226.
Okay, we'll keep 1.92, 2 decimal places. So we're going to eliminate the negative because time is positive. Any real application is a positive answer. So it's going to take our water balloon about 1.92 seconds, which is pretty quick. 59 feet, about 2 seconds to hit the ground. So I'd like you to go to the bottom of the page and look at the science competition. I remember when I was in, I think, 6th or 7th grade, we made a container for an egg, and we went on the top of the school. Well, we didn't, but our teacher went on the top of the school and dropped it. Did you guys do anything like that? Yes.
Yeah, we
6th
dropped it
grade?
from the
Last year, 8th grade? Okay. So and you were supposed to like see if the egg would stay whole or if you didn't do a good job protecting your egg and it broke. So we have the same thing here. Science competition, students have to design a container that prevents the egg from breaking when it's dropped from a height of 50 feet. How long does the container take to hit the ground? And there's a little guy over there who looks pretty excited. His egg must have been okay. So see if you can plug in the information and figure out the time that it takes for the egg to hit the ground. I guess we don't know if it survives or not. Did anybody's egg survive? Ooh, yeah, a couple of you, nice.
Mine didn't because Michael broke the egg before we dropped it.
Oh, so you're blaming it on Michael.
Because
Uh-huh.
not him.
Not,
Michael
oh,
Wagner.
different Michael.
Michael Wagner.
Oh, I don't know him.
Oh, that makes sense.
Wow, that's a low blow.
Because he sat on the egg.
So you're not blaming it on a faulty container, you're just saying it was his fault.
See, if it's broken before it hits the ground, then technically it's not where you broke it. Then technically it doesn't break when it hits. So.
I guess that's true. Alright, so we have 0 is the height of the ground. If it's hitting the ground, it'll always be 0. If a person catches it, that's when the height will be different. And it'll say it is caught at a height of 3 feet above the ground. Or a child catches it at a height of this foot, or feet above the ground. So it'll say how high the ball is or the object is above the ground where it's caught. If it hits the ground, it's just a 3 there. Or 0 there, I'm sorry. So we're taking the 50 to the other side. And then we're dividing by 16. So we have 50 60ths. And we're taking the square root. So you're taking the square root of 50 16ths, not 60ths. Oops. So how much time does it take a ball to, or an egg to fall 50 feet? Brady.
1.77 seconds.
Nice job. And again, we don't worry about the negative in real life applications. So 1 and what? 1 3/4 seconds. You don't have to simplify. We're just going to put that in a calculator. So no, you wouldn't get points removed if you did simplify it. Real life applications will be nice. So I don't want you to do all of this before you pack up. I think I have a minute and a half. I'd like you to do 1 through 9. So 1 through 9 at the top. And then 14 to 36 even. Make sure you keep the answers exact unless it's the word problem is the only one, the last problem 36. The answers are posted on Google Classroom. Please check your answers. On Monday, we're going to learn about the imaginary number. Oh, sorry, Brady. You ready?
Michael, would you go in your essay?